Seeing Smarter, AI's Vision Revolution, synthesizing 94 papers from 2025-09-25 to 2025-09-25, exploring cutting-edge computer vision research from efficient detection to physics-aware generation, highlighting real-world impacts and innovations. Presentation Overview. A grand tour of computer vision frontiers. A dive into 94 fresh papers on computer vision's pulse is presented. Stories of AI seeing smarter in urban nights and beyond are woven. Themes, findings, methods, and spotlight papers are unpacked. Engagement with efficiency, multimodality, and ethical advances occurs. The episode ends with future paths and ways to stay connected. Field Overview. Understanding computer vision. Computer vision enables machines to interpret visual data like human sight. Its roots trace back to the 1960s, and it is now powered by deep learning and massive datasets. Applications include self-driving cars, medical imaging, and augmented reality. Challenges encompass data biases, high compute needs, and privacy concerns. These papers advance efficiency, generalization, and multimodality. Research Theme 1. Efficient models for edge deployment. Slimming AI for real-time use. A key theme is optimizing models for devices like phones and drones. Zhang et al. Introduce MS-YOLO for lightweight infrared detection. Compute is reduced to 6.7 gigaflops with a custom loss for accuracy. DEIMV2 by author scales detection across model sizes efficiently. Urban safety apps are enabled without cloud dependency. Research Theme 2. Foundation models and multimodal integration. Versatile AI for images, text, and more. Pre-trained models that handle diverse data types are being built. Rautela et al.'s MORPH generalizes PDE simulations across dimensions. Decipher MR by authors fuses vision and language for MRI tasks. Fantasy World unifies video and 3D for consistent predictions. Applications in medicine and virtual reality are boosted. Research Theme 3. Generative and physics-aware synthesis, creating realistic content with controls. Focus is placed on generating plausible videos and images grounded in physics. Yu Yuan et al.'s NewtonGen infuses dynamics into text-to-video. Hunyuan 3D Omni handles multimodal 3D asset generation. SimDiff constrains diffusion for accurate motion synthesis. Education, gaming, and AR are enhanced with controllable outputs. Research Theme 4. Robustness, evaluation, and adaptation. Probing AI weaknesses and biases. Vulnerabilities, benchmarks, and domain shifts are addressed. CompareBench tests visual reasoning, revealing temporal gaps. Studies on biases in AI images expose gender stereotypes. The DAC framework uses co-training for medical adaptations. Ethical, robust systems for real-world reliability are built. Key findings. Groundbreaking insights across papers. Efficiency is advanced with Zhang et al.'s MS-YOLO cutting overhead for edge infrared detection. Generalization is achieved through Rautela et al.'s MORPH, excelling in zero-shot PDE predictions. Evaluation via CompareBench shows models struggle with temporal reasoning. Generation is innovated by Yu Yuan et al.'s NewtonGen, creating physics-consistent videos. Robustness is enhanced as quantization improves out-of-distribution detection. Methodology. Synthesizing common approaches. Diffusion models involve iterative denoising for generation, as seen in NewtonGen. Transformers use attention for long-range dependencies in MORPH. Contrastive learning pulls similar features closer for robustness. Chain of thought enables step-by-step reasoning in multimodal tasks. Strengths include high quality and generalization, while limits involve compute intensity. Selected Research Paper 1. MS-YOLO, Infrared Object Detection for Edge Deployment via MobileNet v4 and Slide Loss, by Zhang et al. Selected for innovation in efficient edge AI. Justification lies in the novel loss tackling imbalances, enabling real-time urban safety. A lightweight backbone reduces compute while maintaining high precision. Impacts are seen in autonomous driving and surveillance applications. This represents the efficiency theme with broad real-world potential. Selected Research Paper 2, MORPH, Shape-Agnostic PDE Foundation Models, by Rautela et al., chosen for generalization in scientific modeling. Justification includes zero-shot capabilities across dimensions, accelerating simulations. Convolutions and attentions are blended for flexible PDE handling. Advances are made in climate and engineering fields with efficiency. This exemplifies foundation models' interdisciplinary impact. Selected Research Paper 3, NewtonGen, Physics-Consistent and Controllable Text-to-Video Generation via Neural Newtonian Dynamics, by Yu Yuan et al., picked for physics integration in generation. Justification encompasses controllable, plausible motions outperforming baselines. Neural dynamics are added to diffusion for realistic videos. Education and VR are enhanced with user-guided physics. This highlights the generative theme's novelty and applicability. Future directions. Next steps in computer vision research. Deeper multimodal fusion with audio and sensors is expected for holistic AI. Ethical biases and sustainability in compute demands must be tackled. More edge-friendly, robust models for healthcare and environment are anticipated. Benchmarks for emerging challenges like anticipation will be developed. Interdisciplinary pushes toward ethical, anticipatory vision systems are foreseen. AI synthesis and review. How this deck was created. Synthesis occurred using AI tools. GPT Grok with model Grok 4.0709 for content generation. TTS synthesis was performed via OpenAI for audio narration. Image generation utilized Google tools for visuals. Review by a human expert ensured accuracy. Note that potential oversights may exist. All references are provided. Subscribe and channel info. Stay updated with AI frontiers. Subscription to the YouTube channel is encouraged for more research deep dives. The title is AI Frontiers. The description is provided. Hit subscribe to explore bleeding-edge AI storytelling. Join the community and share thoughts. In this podcast, we bring you the latest breakthroughs in computer science and AI, straight from arXiv preprint server. From neural networks to quantum computing. We simplify complex research so you can stay ahead. Whether you're a developer, researcher, or tech enthusiast, AI Frontiers keeps you informed daily. Thanks for listening. If you enjoyed this episode, subscribe for daily updates. See you tomorrow with more cutting-edge AI insights. Disclaimer, this video uses arXiv preprint server content under its API terms of use. AI Frontiers is not affiliated with or endorsed by arXiv preprint server.